Okay, this is going to represent section 2.4 for stats, misrepresenting data. So graphics are really powerful. People tend to look at pictures more than they look at texts, especially if it's on TV. So it's powerful what people see. Misleading graphics are when you unintentionally mislead people or skew the data or make it look weird. Whereas deceptive is purposeful. You are purposefully saying or showing something that you know is going to be confusing. So let's look at this. What do you see and what might be wrong with it? Well, one thing, 20% and 8% don't total 100. So we're not really sure what each thing represents. We're not sure what happened to the rest. We don't know if these are all other months combined. What they really are is an average. That's the average on the other months. Whereas July and August, they added them together. So that in itself is deceptive because it's saying, hey, 20% is just in these two, while the rest is 8. That's really hard to tell the difference. So just looking at that really quickly, if you didn't pay attention to all those details, you would say, hey, burglaries are really bad in July and August. Now let's look at this one. This is the real data for all of them. Why is this better? Well, this compares all of the months separately so that you can actually see the differences. Here, August is actually less than a couple other months. So this is what shows us that they combined these two together and just averaged the other percents. Why would the company have done that? Well, this is going to make people startled and go, oh my gosh, there's a lot of burglaries. I need to take care of something. So that's more likely to spur action and spur people to buy things. So now let's look at this one. News organization talks about marginal income tax rate, 2012 versus 2013. So if we look at this, the tax rate increased. It looks like it increased a lot. So what's wrong with this graph? Well, the biggest thing is it doesn't start at 0. So over here on the y-axis, it doesn't start at 0 and it doesn't show us. It doesn't use like the little lightning symbol to say, hey, pay attention. And that's actually going to distort the data. If you look at one that starts at 0, that percentage, it's less than 5% that it increased. It still increases, but it's a lot less than this looks because these are all by ones. So looking at this, it doesn't show you quite as much. There's no distortion. Why might the company have used this? Well, they're trying to promote something to get you to either lower your tax rate or buy something to help. So they're making it look like a bigger jump than it really is. All right, how about this? 3D graphics are awesome. People like looking at them. They're great in presentations. They're also really easy to manipulate. So this bar graph illustrates how people flush a public toilet. What's wrong with it? Well, one, we don't even know where it starts. Where does it start? So are we starting here on the toilet paper? Are we starting at this line? Are we starting at the bottom of the toilet paper? We don't even know where the scale starts or what the scale is. There's nothing given. And then if we add those up, 41, 30, and 17 only gives us 88. So A, it's not 100%. What do the other 12 people do to flush a toilet? Maybe they don't. I don't know. And the other thing, it's not really to scale, right? So if this is 30 and this is 17, it should be about half, right? And it's not. It's not even close to half. So the scale's not even helpful on here. There's really no redeeming anything in this other than it looks cool. How about this? In 1991, there's approximately 10 million people in the United States who played soccer. By 2009, there was 14 million people. They used this graphic. Why is this misleading? It shows that it's got bigger. That's true. But if this is 10 million people, let's say like each of these squares, 1, 2, 3, 4, 5, 6, 7, 8, maybe a million people. So this one should only be like 4 squares bigger, and it's way bigger. So the graphic change doesn't represent the proportion. It doesn't match the proportion of change. Now, someone doing this might be trying to sell like soccer cleats or soccer balls, and they're saying, hey, so many more people are participating, you need to jump on this board. And it is a lot. I mean, 4 million people is a lot, but it's not as much as this picture represents. So 3D graphs, you really want to be careful. Let's look at another 3D graph. So this graph right here shows the educational attainment of U.S. adults in 2013 with the table right next to it. So on this table, high school diploma is the biggest. But on this chart, that is not the biggest looking chunk. It also shows our graduate professional degree is 20,000 versus some college is 34,000. Compare those two. The size doesn't match at all. They look smaller than the ones they shouldn't look smaller than. And what if we spin it? So this is the same exact chart, just spun around. Should represent the same data. And now all of a sudden, look how different the associate degree chunks are looking and the some college chunks are looking. So with the 3D graph, even if it's intended to be nice and pretty, it's really hard to read this and it doesn't match the data at all. We don't even know what part of the shape. Like, are we only using the top chunk here because this one only has a top? Are we using the whole thing? So this graph, and this one may not have even been intentional. They just might have tried to make it look good, and that's why they showed you both. But just in spinning these, you can see how it changes the perspective. Versus this two-dimensional one, it's not as cool looking. It doesn't pop off the page and look as great, but all of the sectors are using the same scales. The percents are right on it, so you can even compare the numbers and that without having something separate. It just looks a lot more accurate, and you can clearly see which ones are bigger and smaller. Some other things we didn't talk, or like that aren't shown that you want to pay attention to, are titles and labels. So if we go back to the robbery one, how they labeled that. Like if you look at this, just seeing that that's 2 months and this is all the other months should be like a tip off that it's weird. You want to pay attention to white space. Spacing on graphics and pictures can make things look bigger or smaller. Same idea, you want to look at clutter. If there's a ton of stuff in that graphic that doesn't have anything to do with the actual information, it's there to distract you. So if you have too many designs or too many things taken away from the actual data, it's probably there to distract you. And you want to pay attention to your scales. Are they clear? Do they match? Do they add up to things they should add up to? And just see if something's weird in the graphic, it's probably trying to hide something in the data. So that is 2-4. Let me know if you have any questions.